And thank you. My name is Carlo Abate, and I'm going to talk about the ReGreen pilot, which is one of the many pilots that are going on in the EOSC DIH program. This project is about a solution to find places that are suitable for the generation of renewable energy from multiple renewable energy sources. The idea of the project came because, well, one of the problems that are hindering renewable energy sources is that they are more unreliable than, for example, fossil fuel sources. And as you know, energy is only useful if it's available when and where you need it. And therefore, the fact that, for example, it's not always sunny because sometimes it's raining and sometimes it's night, it makes it a problem for solar energy generation. And so on. If it's not windy, you cannot produce wind, you cannot produce energy from wind, and so on and so forth. And the other problem is the transmission stability. So voltage and frequency fluctuation in energy generation can potentially create problem to the stability and also to the security of the whole grid system. So what normally what are the normal solutions for these problems is on the one hand energy storage, which obviously mitigate the problem of energy unavailability. Because, well, if you have a battery, then of course you store energy during the day, and then you have your energy during night, for example, if you need it or when it's not windy. But this is just shifting the problem from the depletion of fossil fuels and the impact that fossil fuels have on climate with the problem of depletion of the resources that are necessary for the batteries. And at the same time, the other solution that is commonly used is the direct distribution of solar and wind energy to a grid, which, well, solves the problem of the battery, because you don't have the batteries, you are directly using this into the grid and supplying it to whoever needs it. But then from the point of view of the transmission, you might have problems because of the voltage and frequency fluctuations, and therefore what you need is a system that is able to balance all the time the generated energy with the demand of energy, and you compensate the fluctuations caused, for example, by overgeneration or by undergeneration of energy, and therefore you need a system that keeps the voltage and frequency in the grid stable. Otherwise, you risk to have grid congestions and electric losses. So what this pilot is about, and it will investigate in the next 9 months or less, is an idea of having cogeneration of multiple energy, multiple renewable energy sources at the same location. And the idea is that if you do that, well, on the one hand, if you have multiple energy sources, then you reduce the probability of all of them being at the same time all unavailable. And on the other hand, you can create a local system which is optimized to compensate the fluctuation in the system. And therefore, when you then transmit the energy to the grid, then you are transmitting something which has a relatively stable voltage and frequency and so on. And just to give you an example, if you combine solar and hydropower in just one production site, the excess of energy that is produced by solar panels, for example, it could be used to pump water upwards and have therefore a reservoir of water at a higher position. And then when it's night, or when you have any problem, any cloud or something like that, then you use this water to compensate the reduced energy production from the sun and have a stable production. So in this sense, the idea is just an enabler to foster the penetration of RES, so renewable energy sources, And therefore, what we want to propose is a solution that identifies the sites that have a high potential of energy generation from multiple renewable energy sources at the same time. And the sources that we are considering are hydropower, solar, and wind in the pilot. The way we're going to do it, we want to combine different sources of data, so satellite observations, reanalysis, ground elevation data, and RES power output, so the power output from renewable energy sources. And the idea is to train an artificial neural network or some other kind of artificial intelligence algorithm. We will test different options to see the one that works the best by having also the least computational power required, and associate the features that will be, for example, the radiation, temperature, wind speed, terrain elevation, slope and orientation, humidity, cloud coverage. These features, combine them and associate them with power generation data so that the algorithm learns to associate some kind of geographical and atmospheric and meteorological condition to a power generation value. While doing this, we create an energy generation potential index, which is located, it's going to be a geographical index. So we will have, for example, the focus on of the pilot will be Italy. So we will have a map of Italy with the energy generation potential from different energy sources, renewable energy sources. And then we will create 3 of this map, one for hydropower, one from wind power, one from solar power, and merge indexes in one global index that gives the potential to create, to generate energy from multiple sources at the same location. And this is basically the idea, what we will gonna try to do in this pilot. Well, this is just a preliminary work plan to give you an idea of when the results will be available. So the first phase is gonna start well soon. Well, we have already started, in fact, but just recently. We will have a data collection phase in which we will try to understand what are the best data that we need. So if we need, for sure, we will need solar irradiance to know what is the energy that comes from the sun at different location, but and the wind speed and so on. But we will try different combination of parameters. Then we will test some models to see if which machine learning algorithm will work the best. Probably we will need some neural network, but it's not sure, because maybe we can do something good. We have you know, satisfactory results also with some less computationally intensive models. Then there's going to be the training and testing, and finally, in the last 2 months of the project, we will build a visualization interface that will make us able to, well, the potential user will be able to interact with the maps and see, zoom in, zoom out, check what are the actual information of different locations and so on. And now, just a few words about us, about DeepBlue. So, well, we joined the EOSC DIH program through an open call for application, obviously, but we as a company are a research and consultancy company based in Rome, in Italy. We have, well, quite a, 22 decades experience in research and development projects, training, consultancy, and so on. We have, well, so the company itself is quite big. The group where I work, which is the group of data analysis and visualization, is not as big as the company. We're just five colleagues, with one that has a specific expertise in energy generation. And as a company, we are the first SME in Italy for EU net contribution. So we participated. We normally participate in several European projects, and we are the 4th in Europe, SME in Europe for that. And in general, we have, as I said, experience both in research and consultancy. So we have quite some track record in consultancy activities since 2001 when the company was founded. And the expertise varies. We started with research and consultancy in aviation, and then throughout these 2 decades, we somehow expanded our expertise to various sectors. So aviation, air traffic control, maritime, and more recently rail, healthcare, and energy and environment issues. And the expertise varies from user-centered design, human performance, communication and dissemination. And then in recent years also, we started to be more and more involved in modeling activities, data analysis, and also the development of machine learning techniques that are, well, so far we have mostly applied them in the air traffic management sector, but we are trying to apply this expertise also to other domains, and this is why we are here to try to apply this expertise also to the energy domain. And that's all from my side. Thank you for participating, and if you have any question, I will be available here